Hello, welcome to the class of IPv6 course. So today we are going to discuss about the auto configurations and the path discovery processes. So in this class we will discuss about the stateful process of auto configuration, then the network renumbering, and after that the path MTU discovery. So starting with the first process, that is the auto configuration. So here IPv6 address have a ability to auto configure automatically in the network. So here, as in IPv4, the addresses are configured automatically or from the DHCP server. So it make the life of the auto configuration make the life of the network administrator easier, as especially when we have to allocate the address to a particular device. So here the benefit of auto configurations are like less workload on network administrator, as well as it make the easy configuration of the large addresses in IPv6. So these are the benefit of auto configuration. So here the IPv6 device can configure complete or part of address space for its automatically. So here it will configure some either the complete address, or it will can configure a part of particular address automatically. So here the auto configuration methods are of two types. The first one is stateful auto configuration, and another one is stateless auto configuration. So here in stateful auto configuration, the IPv6 addresses are assigned with the help of DHCP server, that is dynamic host configuration protocol server. Whereas in stateless auto configuration, the devices and router have 64-bit prefix and 64 bits of interface ID. As we have discussed about the packet format of IPv6, we know that the 64-bit prefix are there, and after that the address has the 64-bit of interface ID. So here in stateless auto configuration, the interface ID addresses are derived with the help of EUI64 process. About this process we have discussed in earlier lecture. So here in the interface ID is automatically derived from the DHCP server in IPv6. So here the SLAAC use neighbor discovery protocol to configure addresses. So here the neighbor discovery protocol is used to configure the stateless auto configuration addresses. So here an IPv6 address are leased for a certain lifetime. So whenever the lifetime expires of the particular address, then the particular address will become invalid for use. So we have to use a particular IP address that is not invalid in the network. The next we are going to discuss about that is SLAAC, that is stateful auto configuration. So here in stateful auto configuration, it provides plug and play IP connectivity in two phases. The first one phase is that is link local address assignment, and the phase 2 is global address assignment. So here in link local address assignment, what happen here, we are providing the address to device that to provide a connectivity in a particular network or in a particular geographical area. Whereas phase 2 global address assignment is a method in which we are providing an address to a device that it can communicate with the other devices or the external network efficiently. So first of all we will discuss about the first process, that is phase 1 link local address assignment. So here there are some steps to provide the link local address. So here it is used for providing local connectivity. So first step here is to that contain the generation of link local address. So here we have to generate the link local address. So here whenever a multicast capable IPv6 interface or a device is turned on in a network. So whenever we connect the IPv6 device in a network, and then a device generates a link local address for a interface, and this is done by giving interface ID to the link local prefix, that is FV80:10. So here after that the next step is execution of DAD algorithm. So here the DAD algorithm is duplicate address detection algorithm. So here for prior the assignment of the new linked local address to its interface, the node must verify the address that address is unique or not. So this is done by sending a neighbor solicitation message to a new address, and if there is a reply then the address is a duplicate, and if there is no reply from the message then it means it is not a duplicate address. So if the address is duplicate then the process will end there, and now the operator must take the concern about the address and we can assign any unique code manually. After that the next process is linked local address assignment or the assignment of linked local address. So here the next step, here if the address is unique, if that here when we run the DAD algorithm and the result will come that the address is unique. So here if the address will unique, the node assign it to the interface. So the address will be assigned to the interface here. So this is how we can provide the linked local address to a device so that it can communicate in a local area. After that the next step is phase 2, that is global address. So here this global address phase 2 process is used for providing global connectivity. So here there are steps. That first step is sending router advertisement message. So first of all we have to send a router advertisement message in a network. So here the node sends a router solicitation message to all on-link router to send it router advertisement. So when the router is enabled to provide stateless auto configuration support, the router advertisement will contain a subnet prefix that can used by the neighboring host. So here next step will contain the generating global address. So now the global address is generated after the router advertisement message is sent. So here as we get the prefix, subnet prefix of a network, then what we will do, once it receive a subnet prefix from a router, the next step is the host generate a global address by using the interface ID, and we will use that interface ID as compared to that subnet prefix. So next step will contain execution of DAD algorithm. Now the same steps are following. Now we will execute a DAD algorithm, that is the host will again perform a duplicate detection, like this address is present in a network before or not. So this time for a new global address we are performing this duplicate address detection algorithm. And the last step will assignment of global address. So we will assign the address to a particular device if that particular device is not a duplicate and it is a unique one. So we will assign that address to a host interface. So these are the two phases, that is phase 1, that is link local addresses, and this another phase will decide about the global address. Now we will discuss about the state of IPv6 addresses. So first of all we will discuss about the state of IPv6 address. There are 6 states, that is tentative address, preferred address, depreciated address, duplicate address, valid address, and the last one is invalid address. So here the first one is tentative address. That means it is an address that is not assigned yet in a network. It means we are not using that particular address. So it is a state prior to the assignment of the address to a particular device. So here what happened, we will verify the uniqueness of a particular address before assigning to a device. So here a node cannot communicate in the network using a tentative address, and the only message that can be processed with using a tentative address is that we can use a neighbor discovery message to run the auto configuration process. So these are the tentative addresses. The next one is the preferred address. So here the preferred address are the addresses that has been assigned to an interface and can be used without any restriction for a lifetime assignment. After that the next is depreciated addresses. So here the use of this address is discouraged or banned, because a depreciated address might be one whose lifetime is about to expire, and we cannot use these particular addresses to be assigned to a new device in a network. So it can still be used to continue a communication that will disrupt a service if the address changes. So it is no longer used as a source address for a particular device. The next one is a duplicate address. So duplicate addresses are used to test the uniqueness of an address by using a DAD algorithm, that is duplicate address destination. So here the next address is valid addresses. So here these valid addresses are used both for the preferred address and the depreciated addresses. So the valid addresses are those addresses that are assigned to a particular device and they are well communicating in a network. The next one is the invalid address. Invalid addresses are not assigned to an interface, and a valid addresses become invalid when its lifetime expires. So these are those devices at one time they are valid, and after some time when their lifetime expires they will become invalid addresses. So these are the 6 type of states that can be managed by the IPv6 address. So here before and after an IPv6 address is assigned, it goes through various states such as tentative address, duplicate address and preferred addresses and so on. Next we will discuss about the how to generate interface ID. So interface ID can be generated by using two methods. The first method is permanent IPv6 address and the next one is temporary IPv6 address. So in first one, here the global unicast address is assigned to interface either manually or by using a auto configuration method. So here it doesn't change as long as the interface is enabled and active. It means it will remain permanent. In the network. The next one is the temporary IPv6 address. Here this globalcast unicast address is assigned to interface that use a random interface ID and that has a limited lifetime, and it changes regularly and configurable interval. So these are the addresses that can be chosen randomly interface ID that have the limited lifetime, and it can be changed regularly or using a configurable interval. So these are two methods of generating interface ID. First one is permanent and second one is temporary. Next we will discuss about the network renumbering. So here the renumbering a network means replacing an old prefix with a new prefix. So this is done to develop a new addressing concept in a network. So here the reason for replacing the prefix, the first one is like change of operator. So as the change of operator is called, it will usually imply a change of prefix. After that, the next is movement from IPv4 word to the IPv6 word. As we are doing the transition from IPv4 to IPv6, now we will have to change the prefix. After that, the next is concept of having multiple addresses to a node. So these are the reason of replacing the prefix. The next we will discuss about the path MTU discovery, that is path maximum transmission unit discovery. See here the path MTU discovery is a technique that will determine the MTU size on a network path between the two nodes. So it will find the MTU size, that is maximum transmission unit size, that we can use send a packet of that MTU size on the network. So here the goal is to avoid the IP fragmentation or the IP packet splitting. Here the standardization of IPv4 path MTU discovery is defined in RFC 1191 and for IPv6 it is defined in RFC 1981. So here this also support the multicast destination addresses. So here the PMTUD was originally designed for router in IPv4, but in IPv6 router cannot fragment send the packet anymore. So here we will use the IPv6 for the devices. So this work of fragmentation is done by the sender of a packet. So here we are using this path M2 discovery at the sender process. Now we will discuss how this path M2 discovery will work. First of all, the device who is sending the packet over the network, what it will do, the device will believe that the path M2 is same as that the M2 of the first hop link, and it will use that same size. First of all, it will send the packet to the next hop link in the network, and it will use the same path M2 as of itself. So here it will believe that the path M2 is same as that of the M2 of the first hop link. So here, as it will send the packet of that size, after that ICMP version 6, that is packet too big message, is sent back to the sender. So here, if the packet is too big for intermediate router along the path to deliver the packet to the next link, the router discard the packet. So here router will send the message, that is packet too big message, to the sender to indicate that the packet that you have sent have a larger MTU size. After that, the ICMP message includes the MTU size of the next hop link. So here what we will do, it use the MTU size of the next hop link, and it will use that much MTU size for a packet. So device use same MTU for sending further packet to the same destination, and when the packet receive at the final destination, the path MTU discovery process will end. So this is the process in which path MTU discovery will work. So this is all about the auto configuration and path maximum transmission unit discovery. Thank you.